I think just I'll show you final answer. So just you can take care of the substitutions. Okay. So I have given you this step. After this step, I have directly given you answer, right? So if you want, you can just make those substitutions, okay, in your book, and then you can write down final answer. So if you do it, then I'll go for next problem. Okay, ma? So those who have not done, just copy it. Second. So we are going to literally present. We are taking the lecture, it is the column and we are adding some other ingredients, which are adding some other ingredients. Doing first special engineering properties. Okay. So our actions are the knowledge of the by mixing the wafer with the other ingredients to inform special properties. So here, here, right, means what are the properties are there for example, they have high corrosion, easy versatility, so I get the help quality training of more with the high chemical emergence, low retention function, high abrasion resistance, impermeability to water, impermeability to water. That's one about what consumption of. When you are using the plastic, they only after they are like how the steel works. Students, done, ma? Ma, shall I go for next problem? Students, shall I change slide now?
Yes, ma'am.
Okay, we'll go for fourth problem. So all of you copy this problem. Take down question. Amma, you have started copying this problem? Students?
Yes, ma'am.
Yeah. Don't do solution. First, you take down this problem. We'll discuss about the solution and then we'll proceed further.
ನಂದು ಪೆನ್ ಇವ್ರಂದು ಬೇರೆದೆ ಪೆನ್ ಇವ್ವೆ
Risha, mute yourself. Okay, ma. So what is asked in this problem?
position of the Fermi level at 300
Ask the position of Fermi level. Okay.
at 300
So I think similar problem we have done before also. So just looking at the data given. So what is the data given? We were given value of band gap, but this value it is in electron volts. So band gap value is given in electron volts. How to convert band gap given in electron volts to joules? Just conversion is 1.12 into 1.6 into 10 power of minus 19 joules. So we are converting electron volts energy into joules. So this is in joules. And also we were given temperature. It has to be in kelvins. And apart from that, what is given? This effective mass of electron is 0.12 times the effective mass of hole. This rest mass of electron. And similarly, effective mass of hole is 0.28 times the mass of electron. Okay. So we know that this is the formula for Fermi energy level in intrinsic semiconductor. Okay, so this is the formula. This has to be mh star. Somewhere they are using mh star, somewhere mp star. So this is mh star. So again, what we are doing, again, we are taking temperature T is equal to 0 kelvins. So T is equal to 0 kelvins. What happens to Fermi energy level? Here the second term will become 0. So we'll have EF as EC plus EV by 2. Okay. So here, actually this you don't take. So T is equal to 0 kelvins. The second term will go off and we have our Fermi energy level as EC plus EV by 2. So if I draw this band gap, energy band diagram. So here we have EV and this is EC. So this is EV and this is EC. And this is the middle, EC plus EV by 2. So here EF is equal to EC plus EV by 2. That is middle of forbidden energy gap. This is the case at T is equal to 0 kelvins. So here Fermi energy level, it is exactly middle because we know that this width it is equal to Eg. So that's why we can also take this Fermi energy level to be middle of forbidden energy gap. So that concept we have taken here. So here in this case, EF is equal to EC plus EV by 2, which is equal to EG by 2. So here now our expression will get modified. Now what happens to expression now? This expression, it will become as EF plus E, sorry. So here equation, it will get modified as EF is equal to EG by 2 plus 3 kT by 4 ln mh star divided by me star. Okay, so this is the formula, right? So we know Eg. So here I have made substitutions here down. So what is the value of Eg? 1.12 into 1.6 into 10 power of minus 19 joules divided by 2 plus 3. Here we have 3 kT by 4. So 3 by 4 K. Boltzmann constant value is 1.38 into 10 power of minus 23. And what is the value of temperature? So here this formula I'm using. I'm making substitutions in this formula. So here temperature is 300 kelvins. And how I got this ln 5? Because here I have ln mh star by me star. So this is ln mh star by me star. So which is equal to ln. What is mh star? Effective mass of hole. So but what is the effective mass of hole? It is 0.28 times the effective mass of, rest mass of electron. And what about effective mass of electron? It is 0.12 times the rest mass of electron. So rest mass get cancelled. So you just find out, students, what is this value? 0.28 divided by 0.12. So tell me, what is this value? Wow. I think it should be ln of 4, I suppose. No, not 4. 12. So tell me this value, students. I think this is not 5. Is it 5? It's not 5, right? Students, are you listening to me?
Yes,
Tell
ma'am.
me, what is the value of 0.28 divided by 0.12?
2.3.
2.3, huh? Yeah. So here it should not be 5, I suppose. Am I correct, students? What I'm doing is correct? So here you people modify it as, in place of ln 5, you should have ln mh star by me star. But what is mh star? 0.28 m naught. Me star is 0.18 m naught. So here in place of this ln 5, we'll have ln of 2.3. Okay. So I think I made this mistake. All of you make that correction. So if we just take ln of 2.3, so what is our final answer? That final answer, it comes out to be EF is equal to 0.576. I don't know, this value it is given in electron volts. But you people tell me, calculate this value and give this value, it will be in joules. All of you just do it and tell me what is the value of EF in joules. If you have calculator, do it. When you make use of this formula, you will have your value in joules. But again, if you divide it by 1.6 in 10 power of minus 19, you will get this value in electron volts. So if anyone has done this in joules, please let me know. Calculate this total value and tell me what is the value of EF in joules. Anyone is doing? Anyone is doing? Can anyone tell me answer in joules? I want Fermi energy value in joules, students. If there is no use waiting for you, so I'm going to go for next problem. So you people calculate this. You got it, ma? What is that answer? Tell me again. How much?
8.972 into 10 power minus 20.
8 point, huh? Huh?
Yes, ma'am.
Is it 8 point? 8.972, na, ma?
Yes, ma'am.
Into 10 to the
10
power
power
of
minus 20.
minus 23, yeah?
20,
20, yeah? Okay. So 10 to the power of minus 20. So this value will get in joules. But how to get it in electron volts? So this value I have to divide it by. So what I have to do? 8.972 into 10 to the power of minus 20 divided by what I have to do? 1.6 into 10 power of minus 19. So if I do this, then I think we'll get this answer, 0.576 electron volts. Okay, ma. Who has given this answer? May I know roll number? Roll number of student who has given this answer.
318. ma'am.
Who is this?
318.
Okay, ma. Very good. Good. Okay. So shall I go for next slide? I'm changing slide. So we'll go for next problem. So this is our problem, students. So all of you note down this. So take down this problem. So we are taking state down chain bodies. Okay. So next is here thermosetting intelligence. Thermosetting resistance. These are linear. These are how we are getting here. The vector how we get coordinate structure. The coordinate structure will be getting vector structure. Three-dimensional vector structure. Later, strong covalent bonds. Thermoplastic techniques are having strong covalent bond and weak covalent bond. Thermoplastic techniques are having weak bond and strong bond. First copy problem and we'll look at the solution. Okay, students. So you have taken this problem? My students, are you done with problem? So here we are taking phenomena of Hall effect. Okay. So if you just look at the data given. So what is given here? So just I'm reading out the problem. So in Hall experiment, Hall effect experiment, how much current? 25 amps of current. It is being passed through a long foil of silver, and we are taking a small piece of silver. And what are the dimensions of silver? Dimensions of silver is it is 0.1 mm thickness. It has got, and it is 3 centimeter wide. So width is 3 centimeter and thickness is 0.1 mm. And of course, we are making this much of current pass through that silver. And then next, what we are doing, we are subjecting that foil to a flux density of 0.14 Weber per meter square. So this has to be Weber per meter square. So it is applied perpendicular to the foil. And what we are supposed to find, we are supposed to find Hall voltage, and also we have to find mobility of electrons in silver. Okay, so current is given, dimensions of silver is given, magnetic field is given, and also we were given data conductivity of silver. So we were given value of conductivity of silver. So what is the value of conductivity of silver? 6.8 into 10 power 7 ohm inverse, meter inverse. And also we were given value of Hall coefficient. What is the value of Hall coefficient? Minus 8.4 into 10 power minus 11 meter cube per coulomb. Okay. So just looking at the data given, we were given value of current, we were given value of magnetic field. Okay, so this is Weber per meter square ma. Or we can also write it as 0.14 Tesla. Simply we can put it in Tesla because 1 Tesla is Weber per meter square. And what is the thickness of this slab? Thickness of this slab is 0.1 mm. And we know that 1 mm is equal to 10 to the power of minus 3 meters. We have to convert data given in mm or centimeter in meters. So that's why here I'm multiplying it with 10 power of minus 3. So I have converted thickness into meters. And then what is the width of this slab? Width of this slab is 3 centimeter. So here it is in centimeter. And what is that conversion? 1 centimeter is equal to 10 to the power of minus 2 meters. So that's why if I want to convert the 3 centimeter into meters, 3 into 10 power of minus 2 meters. And conductivity of silver is 6.8 into 10 power of 7 ohm inverse meter inverse. Okay. And this Hall coefficient value, this Hall coefficient is minus 8.4 into 10 power of minus 11 meter cube per coulomb. This is the, see, you people have to remember these units. Units are very important. So what are the units of Hall coefficient? Meter cube per coulomb. Okay. And this conductivity is ohm inverse meter inverse. So this is the data given. Now what we need to find? What we need to find? So we need to find Hall voltage. So we need to find the value of Hall voltage VH. Also we need to find mobility. So here mobility mu. We need to find the value of mobility mu. So this we have to do it. So shall I change slide, students? Ma, have you copied? Shall I go to
Yes,
next
ma'am.
slide?
Yes,
Yeah,
ma'am.
I'm going to next slide. See here. So first I'm trying to find Hall voltage. Okay, so actually here, this is not D ma, it should be T, thickness. I'm writing this formula again. So Hall voltage, it is given as RH. RH is Hall coefficient, B is magnetic field, I is current flowing, and down we have thickness T. T is thickness. Okay. So what is each, what like if you want to just make clear each term, what is RH? RH is Hall coefficient. RH is Hall coefficient and B is magnetic field. Applied. Okay. And of course we know I is current, which is made to pass through our semiconductor, and T, this is T ma, thickness. T refers to thickness. So here this is thickness of foil. Thickness of foil. So RH value, what is the value of RH? RH is given as, so RH value is 8.4 into 10 power of minus 11. So here minus sign is there. See what here I told you that RH value, it will be negative if we are selected material is N-type semiconductor where majority charge carriers are electrons. And whereas if majority charge carriers are holes, as in case of P-type semiconductor, then RH value is positive. But when we are doing numericals, we don't have to bother about that sign. So no need of substituting that sign here. Simply directly I'm going to substitute the value of Hall coefficient. I think here we should have minus 11, right students? We missed that minus 11 here. So here we should have minus 11. So RH value is 8.4 into 10 power of minus 11 into how much, what is the value of B? B is 0.14 Weber per meter square, and how much current we are passing? 25 amps. And what is the thickness? Thickness is 0.1 because we have converted mm to meters. So here we have to do 10 power of minus 3. So all of you just look at this calculation, students. Is it 29.4 into 10 power of minus 3? This is in volts. Just check this value whether it is correct or not. So here we got Hall voltage, but we need to find even what else we need to find? We need to find mobility. So what is the formula for mobility? So actually mobility, it is given as sorry, Wait, ma, 1 second. So here conductivity, sigma. Sigma is the notation for conductivity. It is given as Ne mu. So from this, what is our mobility? So mobility mu, what is the formula for mobility? Mobility mu is equal to sigma by Ne. But we know that Hall coefficient RH is 1 by Ne. So this formula we can write it as RH into sigma. And what is the value of RH? RH is 8.4 into 10 to the power of minus 11 into what is the value of sigma given? So if you just go back, so here sigma is 6.8 into 10 power of 7. 6.8 into 10 to the power of 7. So here we have 6.8 into 10 to the power of 7. 6.8 into 10 to the power of 7. Okay. So just calculate and see what is the answer. You calculate this mobility and tell me what is the answer for this mobility. Yes, students. Are you able to understand this problem? Any doubts? Can anyone tell me value of mobility, students? Just find mobility value and tell me how much value we are getting here.
Five 5.712 into 10 power minus 3, ma'am.
Second, I'll write down the value. How much? 5.712
712 into 10 power
into 10 to the power
10
of
power minus 3.
minus 3. Okay, so this is the value of mobility. 5.712 into 10 power of minus 3. Okay, students. And one more thing. And, this one, we have to take units for mobility, right? So what is the unit for mobility? Units for mobility. So this value, it comes out to be this, okay? And units are meter square, volt inverse, second inverse. Units. Units for mobility is meter square, volt inverse, second inverse. Second inverse. So this is the unit for mobility. Okay. So shall I go for next problem? I'm changing this mark. So we are going for next one. So I think this is a little bit similar to what we have done just now, this problem also. So take down this problem. Here also we need to find Hall voltage, which is developed across the width of the slab. And how much current? 30 amps. Magnetic field is 1.75 Tesla. Right. And of course, we know that in Hall effect experiment, magnetic field always it will be perpendicular to the plane of the slab and to the current. And what is the value of thickness of slab given? 0.35 centimeter. And here, students, we were given value of concentration of free electrons in the metal. And here one mistake is done here. So if you just look at this concentration, this value is 6.55 into 10 to the power of 28. So this power, it came down. So you change it as 10 to the power of 28. So this 28 should go up. So this carrier concentration is 6.55 into 10 power of 28 electrons per meter cube. So just looking at the data, what is given? Current is given, which is 30 amps. Magnetic field value is given, which is 1.75 Tesla. And what is the thickness of this slab? It is 0.35 centimeter. But we know that 1 centimeter is 10 power of minus 2 meters. So this is the value in meters. And of course, we were given concentration of electrons, which is given by N, which is 6.55 into 10 power of 28 electrons per meter cube. And what we need to find? We are supposed to find Hall voltage. So we need to find Hall voltage VH. Simple. Okay. So I'm changing slide, students. Shall I change slide?
No, ma'am.
Okay, copy it fast. Changing slide, ma. Okay. Just look at the solution, students. In one small mistake done here. So it should be T. Here this formula. What should be the formula for Hall voltage? RH into B is magnetic field into current divided by thickness of the sample. Okay. And but we know that what is RH? RH is 1 by NE. RH is 1 by NE. So here, so in place of RH, I have to substitute 1 by NE. This is T, not D. It should be T. T is thickness. So in place of RH, I have to substitute 1 by NE. So if I substitute 1 by NE, what is our modified formula for Hall voltage? It is B into I divided by N into E into T. B is magnetic field. How much magnetic field? 1.75. I is current. Current is 30. Okay. And N is carrier concentration. What is the value of carrier concentration? 6.55 into 10 power of 28. And charge of electron is 1.6 into 10 power of minus 19. And what is the thickness of sample given? 0.35 centimeter. And when we convert it into meters, it will become 0.35 into 10 power of minus 2 meters. So I think if we simplify this, final answer will be 14.313 into 10 power of minus 7 volts. Okay, so but we know that if I want to convert it as 10 power of minus 6, this is our value. I think in previous also, just one student, 1 minute, ma. I think I made some mistake in the previous problem. So what is the answer we got here in previous problem? This should be, I think, minus 6 students. All of you change this answer.
Yes, ma'am.
It's fifth
That
problem.
2.94 into 10 power minus 6.
Ade gadra. So this is wrong. So at that time you didn't tell me. Huh? So this value, it should be 2.94 into
10 power
entera?
minus 6.
2.94, sure.
Yes, ma'am.
I think
2.94
2.94 into
into 10 power minus 6.
10 power of minus 7 వస్తుందేమోరా.
Minus 6, ma'am. Calculator lo chesna.
అవునా, sure.
Yes, ma'am.
Because I've seen textbook. In textbook, this is our answer. 29.4 microvolts. అంటే మనకి ఇది ఎట్లా రావాలి? 29.4 into 10 to the power of minus 6 volts రావాలి మనకి as per textbook answer. So you people anyway verify with 2 or 3 students and see what is the final answer. Okay, ma? So coming back to our present problem. So we are here. All of you copy this. So one thing what you have to keep in mind is this in the denominator. This is not D, but it is T. T is thickness. Thickness of the sample. So here also we should have T. So note down this value, then we'll go for next problem. So I think it's already 12 o'clock. So I think you people must be having question bank with you, right? Why don't you try remaining 4 problems? I think we have done 6 problems, right? So 4 more are left. So you people do it at home so that we can finish it fast in next class. And then next I'm going to start module 3. Okay, students.
Ma'am,
So which
after
class?
lab,
Oh, lab. As usual, lab 1:30 you log in. Okay, last time we have taken lab, na? So similarly,
ma'am.
we'll take. Okay, today also you'll have lab. We are going to discuss one experiment. Okay, ma'am.
Okay.
Okay, so by 1:30 you people join on this lecture. Then we'll start our lab. And come with your worksheet, ma'am. Okay. So last time I think we have written everything in worksheet, right? So similarly, this week also we'll do one more experiment and you are going to copy everything in that worksheet. And how many of you have uploaded last week's, all week's experiments in your login? Chesara leda previous experiments.
Yes, ma'am.
Yes, I'm sure, we will be sympathetic. As far as I know, I think we'll be sympathetic about it. The government, most about the government will be sympathetic about it. I think, I don't know. Let us wait and see. Thank you very much. Have a nice day. I'm ending it here.
Okay, sir.